Mr. B here. This is 1-2. We will be looking at describing patterns. A couple of things to know. What is a pattern? What are instances? You also want to know what it means to define a variable. We'll then be going through the guided example of example 1. We'll do that in a minute. Once you've got that down, there's another example to go through. Then a couple of more vocabulary words, terms and factors. You're also going to want to know about the commutative property of addition and the commutative property of multiplication. These are important properties. Compare them to the associative property. Your assignment is to do covering the ideas and applying the mathematics. We're going to head into guided practice in just a second. Okay, so here's a guided example number 1, page 14. You can read this, it tells you what to do, but for A it says complete the table to show the number of magazines in the library each month. And so here's the question, in the start of the school year, 0, there's no years passed, what's the number that goes in here? We can see that since I showed it already, it's 3,600. 3,600 is what's going to go into that first one. The pattern is 3,600 plus 22 times 0, so we got 3,600 magazines in the library. Now what's going to happen in year 1? What's going to go on with the amount there? We started with 3,600. How much we add in each year? Yeah, that's right. Yeah, it's 3,600 plus 22. And so what does the pattern look like there? It's 3,600 plus 22 times 1. There's just the 122. So we have 3,600 plus 22, 3,600 plus 22 times 1, and then leaving us now with a total of 3,622. So what's the pattern in the second year? We've done the calculation, so what's the pattern going to look like? Up here it was 3,600 plus 22 times 1, and now down here it's going to be 3,600 plus 22 times 2, or give us 3,644. Now the last line is kind of open. It wants to know what's the calculation. It's the third year, so how many 22s are we adding in here? Yeah, it was 1 in the first year, 2 in the second, looks like 3 here in the third year. So 3,600 plus 22 plus 22 plus 22. So that would be 3,600 plus 22 times, right, 3. And we get for our final answer then 3,666. If we set some variables now, we can define a variable. We're going to say that m is going to equal to the number of months since the beginning of the school year, and then the number of magazines after m months is going to be what? It's going to be, let's see, looks like 3,600 plus 22 times, what were we multiplying up above? We were multiplying by the number of months, so it's 3,600 plus 22m is the answer to that one. Okay, well now we're on to guided practice for 1-2. Paula borrowed $200 from her grandfather today. She intends to pay back the money at a rate of $10 each week. That would be $10 per week. So the first thing we want to do is to make a table to show how much Paula still owes her grandfather at the end of each week. So here in the first one is what this is going to be amount owed, or weeks really, because it's going to be, I think, the number of weeks we want to know about, because in week 0, right at the beginning of time, we have that she borrowed a certain amount, and then week 1, and then week 2. We can go up here, and now that we've done that, what we want to do is kind of define what calculation is occurring. So the calculation is going to be to determine how much money she still owes her grandfather. In week 0, she hasn't paid him back anything, so that's 200. And then in week 1, well, she has paid him back one time, so that's $10 each week, so that's the 200 minus 10. And then in week 2, we've got, she's paid him back twice, and so we want to write this out so we can kind of see what the pattern might be. That's 10 minus 10. So we've got a couple of instances of a pattern. This might be enough, it may not. Usually we might need 3 or 4 instances to really see what's happening with the pattern. But let's try it here with just these 2. So what's the pattern to it? This is 200 that she borrowed, and she's paying minus 10 per week. And how many weeks was this? This was the 0 week. So 0 times 10 is 0, so it's just 200. This is the first week, so 200 minus 10 times 1. And here on the second week, we got 200 minus 10 times 2. And so that's the second week. And what we see here, the 200s are constants. They're the same in each one of these. The 10s are constants. They're the same in each one. What's varying, in other words, what's the variable in here is this term here, the weeks term. Well, we want to know how much she owes, so let's do a quick calculation there. And we see the amount owed here is still 200. In this category, 190, and finally in this last one, 180. So this is our table, and this gives us, I hope, enough information with which to be able to write an algebraic expression. So we want to define a variable and write an expression for the amount of money that Paula still owes her grandfather at the end of each week. So here let's look at part B, and we want to define a variable. So we want to say, well, it looks like it's this weeks category that's varying, so we'll make W the variable to represent the number of weeks. And we can then look at this as saying, well, what's owed? It's 200 minus the $10 per week, and here's the changing item, so that's our weeks. That's where our variable goes. And so now we have a linear equation that's 200 minus 10 times W equals the amount owed. We could graph this. You could write it as a linear equation, put it in your calculator, and graph it. We could solve it. If we want to know in how many weeks will it be 0, we could go in here and say 200 minus 10W equals 0. And we could then solve that for W and find out in how many weeks she no longer owes her grandfather any money. Okay, let's look at another problem here for 1-2. You can read this, it's up there. We've got people going to an amusement park and there's a cost for the rides. Not sure if you can read my writing there. We got rides, water flume, bumper cars, roller coaster, Ferris wheel. Here's the adult ticket prices and the child's ticket prices. What we'd like to do is to complete this table with information about how much is it going to cost for this group in order to get this done. And if we go ahead and build in a little bit more of the table, we can get to the group cost. And we've got, what was it, 4 adults, 7 children, so That's $2 times 4 for the adults plus $7 times 1 for the children. What does it look like here for the bumper cars then? How many adults? 4. Was it cost? $1.50 plus how many children? 7 times the cost is $1. Okay, I think I'm going to go ahead and switch this one over here real quick. Kind of got them out of order, so I'm going to use the commutative property of multiplication, and we'll just make that 4 times 2. That way things are lined up. So this one is 4 times, what's the cost? Plus 7 times, what's the cost? And then lastly, we got the Ferris wheel, 4 times that cost, plus 7 times the cost there. Okay, so now we've got this table filled out. And with this, we could figure out what each activity's cost is. So let's take a look at it. So for B, what is the cost of each activity? And we've got for each one of them what is the water flume is going to be just solving that particular equation. So 4 times 2, 7 times 1, that's going to be 8 plus 7, it'll equal 15 is our dollar. So that's the water flume. The bumper cars were, okay, 4 times 150 plus 7 times 1. So that's going to give us let's see, 6 plus 7 equals 13. And the roller coaster was 4 times 250 plus 7 times 2 equals, we got $24 there. And lastly, the Ferris wheel. And that was 4 times 3. Plus 7 times 250, and that's going to be $29.50 for the Ferris wheel. So now we've got, the amounts. We know what it's going to cost for the group if they ride each one. So we've got this idea of a pattern. Okay, now let's look at this and see what kind of pattern we can pull out of it. If A is going to be the adult ticket price, and C will be the child ticket price. I think that's supposed to say price right there. What kind of pattern do we have? We've got, for this group of adults, let's say the prices change or they want to do different rides, we can get a pattern that we can use for any price to determine what the total group cost would be. The constant in here is, this is the 4, that's the number of adults. Here we have the 7, that's the number of children in the group. Now we want to know if we have some unknown price for adult and child, what's that going to be? So for our unknown ride, what we're going to get will be the group cost. We'll say the group cost, GC, is going to equal the adult cost times 4A, plus the child cost, how many children? 7, so 7C. So now we've got an equation with 2 variables that gives us a breakdown of what is the group cost for an unknown cost ride with 4 adults, 7 children, and we pull that out of the pattern we demonstrated up here with this. Okay, we're going to wrap up this 1-2 with a little bit of a discussion about the associative property of addition or multiplication versus the commutative property of addition or multiplication. Now, that's not to say that it's like one of these versus battles.
Lakers are looking for a big man.
But rather, this is one of the properties. When we're dealing with the associative property of addition or the associative property of multiplication, what we're really looking at here is a change in the order of operations. So this, the associative property of multiplication, changes the order of operations. What does that look like? Let's take a look here at something. So we have 7 plus 5 plus 3. And the order of operations here would say we do the work from left to right. We go from 7 plus 5 and we add 3 to it. So we would do it in that order. And if we're going to use the associative property of addition, that means we could change the order that it occurs. So instead of 7 plus 5, we can change it to be 3 plus 5 plus 7. So now we are, in fact, we have changed the order of operations for this problem. Okay, we're going to look at the associative property of addition, and this also applies to multiplication. And often you might see it with parentheses, but it's not necessary, and I'll show you at the end how this might work. But if I had something like 7 plus 5 plus 3, and the 7 plus 5 is in parentheses, well, with the associative property, that's saying that this is the order of operations, this happens first, then we add in the 3. Well, we could rewrite this as 7 plus 5 plus 3. And the associative property of addition tells us that we can do this. We've changed the order of operations. We've changed the order in which things will be added together. So that's the associative property of addition. Associative property of multiplication, similar idea. If I have 3 times 8 times 27, we want to look at this, and so in this case the order might be like this. I have a parentheses, it's a grouping symbol. 8 times 27 is to be done first, followed by 3 times the product of 8 and 27. Using the associative property of multiplication, we could rewrite this as 3 times 8 times 27. Put that in parentheses, and now we say we're going to do 3 times 8. Now, you may have noticed I didn't really need to put this in parentheses because I changed the order of operations simply by removing the parentheses, because now we work from left to right, so we would start with 3 times 8 times 27. So if they had been removed, it's the same as if I would have had them there. So that's our associative properties of addition and multiplication. Now let's look at it for the associative property of, the commutative properties of addition and multiplication. And the commutative property simply means we've moved something. So 6 plus 3 is the same as 3 plus 6. This is the commutative property of addition. 5 times 2 equals 2 times 5. That's the commutative property of multiplication. So we've got the associative properties of addition and multiplication. We have the commutative property of addition and multiplication. The associative property tells us that we will regroup. The commutative property tells us to change the order. Now we could have something where it doesn't have to be, there don't have to be parentheses in place for the associative property to be used. And the commutative property could be used with parentheses. So the parentheses being there or not doesn't change anything. And I'll show you something that will use both properties. If I have something like this, 7 plus 8 plus 29, and I'm going to use my associative and commutative properties, I could rewrite this as 29 plus 8 plus 7. Well, in this case, I've moved the 29 and I've moved the 7. That's the commutative property of addition. But in addition, what's occurred here is that in this up here, the order of this was first I would add 7 plus 8, then I would add 29. That's the order of operations. We work from left to right. Now here, the order of operations tells us we first add 29 plus 8, then we add 7. So we've changed the order in which things are added. So in this problem, we have a twofer. We have the commutative property of addition was used when we moved the numbers, changed its position. The associative property occurred because we changed the order in which it was done. So look at this as you move on with the lesson. The associative property of addition and multiplication, the commutative property of addition and multiplication are both important to us in algebra. Be important to you to make sure you know how they're being used. Your assignment, it's on Jupiter Grades. Take a look at it. If you need printouts of it, they're here on the website. Pick up what you need from there and enjoy this last little bit of video. Thank you.